In the game of rugby, it is sometimes required of a player to kick the ball from the ground between the goalposts and over the bar of the goalposts. Jonathan is the team kicker and he aims to kick the ball over the bar and between the posts from point T in the diagram below. Given that RP equals 25 meters, RT equals 22 meters, and angle PRT is 90 degrees, answer the following questions. How far is the ball from the goalposts, that is, the distance between T and P? Well, we can just use Pythagoras' theorem here because we have a right angle triangle. We know that the square of this distance is the sum of the squares of the two short sides. So the distance between T and P is the square root of the sum of the squares of the two short sides. To 1 decimal place, this thing is 33.3, and this is in meters. Calculate angle RPT. RPT is this angle here. So one arm of the angle is the line RP and the other arm is the line PT. So the corner or vertex of the angle is P. Well, we could use the sine rule to do this. There's nothing to stop us using the sine rule. We can apply the sine rule to any triangle, including a right angle triangle, or we can use what we know of ratios for sides of right angle triangles. So I'll do it in two ways. I'll start off by doing it using the sine rule. So we're looking for an angle. We use the letter A to stand for what we're looking for. Since we're looking for an angle, we use capital A. Capital letters are used for angles. If this is capital A, then the side that's opposite capital A is small a. So small a is 22 meters. Now we need a side and an angle that's opposite that side, and we have that. This side here we will call small b, small letter for the side. So the angle that's opposite small b is capital B. So capital B is 90 degrees. So we have that A over sine A equals B over sine B. We want to find an angle A, so we can invert both sides of this. Makes it easy to get at angle A. Multiply both sides by small a. So multiply this by small a, a's cancelled, we get sine of A. Multiply the right hand side by small a, we get A sine B over B. So we just plug in for small a, that's 22. Capital B is 90, small b is 33.3. Now, if you don't know already, the sine of 90 is actually 1, but I'll just show you that. And we have to multiply the sine of 90 by 22 and divide by 33.3. So here's the sine of A. To get A, we get the inverse sine of this. So to 2 decimal places, we get 41.35 degrees. Now that's one way to do it. The other way to do it would be to use what we know of ratios of sides in right angle triangles. So we could do this in a number of ways actually. We could look at say the sine of A, or the cos of A, or the tan of A. Let's look at the cos of A. The cos of this angle is the side adjacent to it, which in this right angle triangle is 25 meters, divided by the hypotenuse. The hypotenuse of this right angle triangle, the longest side, is 33.3. So we have 25 divided by 33.3, and if we get the inverse cos of this, we get the same as before. While allowing for rounding error, you know, this is 41.34, whereas we got 41.35, but it's close enough. We could also consider the tan of angle A. That's the side opposite A. Now the side opposite A is 22 meters, divided by the adjacent, which is 25. So I'll just show you that. 22 divided by 25 is 0.88. We get the inverse tan of that, And again we get 41.35. And finally, the other way of doing it would be to get the sine of A. The sine of A would be opposite over hypotenuse. That's 22 divided by 33.3. And that's exactly what we had here actually. So the sine rule for a right angle triangle is leading us to just the value we will get from just getting the sine of this angle. You know, and as before we saw this, the sine of 90 is actually 1 in the sine rule. But anyway, so you know, if you forget these ratios, you can always just use the sine rule. The rules of the game indicate that you must choose a point along the line RS to kick the ball at the posts. Now S doesn't appear in this picture, so S must be a misprint. So I presume it's meant to be the line RT, so he can kick the ball from any point along this line here. Well, Jonathan has to compromise between being as close as possible to the goal mouth and also having a good view of the goal mouth. So if he kicks the ball from here, well, he's closer, of course. The distance is now this distance here, but he has less of a view of the goal mouth. So he's got a tighter angle. If he kicks it from T, he's got this much distance to play with. I just projected a line from the foot of this goal post parallel to the line joining T to the center of the goal mouth. And similarly for the foot of this goal post here, he's got this much to play with. You know, if he's going to face the goal mouth as well as he can. However, if he kicks the ball from here, then you see he's got a smaller distance on either side of this line. And of course, if he gets even closer, even though he has to kick the ball a shorter distance, he's got a much tighter angle. So it depends on, you know, it's a matter of opinion really. To be sure to clear the bar of the goal posts, Jonathan must be able to kick the ball at least 10 meters beyond the posts. If his maximum length of kick is 55 meters, what is the maximum distance that it can be from the point R? So he has to kick the ball a distance of, well, he can kick 55 meters, but because the ball has to go an extra 10 meters beyond the goalposts in order to be sure that the ball clears this bar, well, the maximum distance that this can be is 45 meters. So this is 55 minus 10. So now, what's the maximum distance he can be from R? Well, we have a right angle triangle here, so it's just a matter of applying Pythagoras' theorem. So this distance here is going to be the square root of the hypotenuse squared minus this short side squared. So the sum of the squares of the two short sides gives you 45 squared. So if we rearrange that, we see that this side squared is 45 squared minus 25 squared, so that this side is the square root of 45 squared minus 25 squared. But this is the power of a half to get the square root. So the maximum distance he can be from R is 37.4 meters. So if his distance from R is more than 37.4 meters, then his distance from the goalposts will be more than 45 meters, and we don't want that. So his distance from R can be anything up to 37.4 meters. So he can be positioned anywhere along this line here.